we are going to go over the back page. Okay, so here we go. Now, the whole goal is to be able to solve equations with variables on both sides. So right here it says observe equations A and B on the right. What makes equation B different from equation A? Well, let's compare left and right. Look on the left side of the equal sign. Okay, the numbers in the front are a little different. But let's look on the right side. Oh, it looks like it has one more term on here that has another variable, all right? And it matches its friend over there. So what we can see is that equation B has variable terms on both sides. And that is what we are working on today, how to solve equations that are just like equation B. Okay, we were used to A. This was 7th grade. And now we're entering 8th grade equations. All right, well, I'm going to actually skip all this. If equations have variables on the both sides of the equal sign, use the following steps to solve. So right here it says step 1 is to use inverse operations to collect all the variables on the same side of the equation, and then all the constants. So the numbers without, or the terms without the variables are called constants on the opposite side of the equation. Then after you've done that, you want to solve. Okay, so I'm going to actually break it down one more time. I'm not going to use this one as an example. I'm going to use this one. But right here, I'm going to kind of bullet point the notes that I kind of like to follow. So first off, step 1 would be to draw the wall, because we always want you to draw the wall, okay? And then step 2 would be start with the smaller variable and move it to the other side. So get all the variables to one side. So step 2 is move smaller variable. Okay, move the smaller variable term. And in order to move one whole term from one side to the other, you're paying attention to whether it's positive or negative and doing the opposite. Okay, you're paying attention to whether it's positive or negative and doing the opposite to undo. Okay, so this is the same thing as move all variables to one side. And I always just say start with the smallest one, the variable with the smallest coefficient, or the lowest coefficient in front. Now, step 3 is to move all the constants to the opposite side that your variables are on. So for step 3, I'm going to put move constants to opposite side of step 2. Okay? Then, last but not least, you solve. Okay? Last but not least, you solve using inverse operations, and you undo, really it's multiplication / division, or if you see it, addition and subtraction. Okay, so you solve by using inverse operations. So here we go. Let's go ahead and now practice. So I'm going to do my step 1. Okay, we're looking at 1 here. I'm going to go ahead and do step 1, and what I told you is to draw that wall. Okay, and what I notice is I have, and I'm going to highlight my terms real quick. I have my terms with the variable. They're raised to the same exponent and they have the same letter, so they're like terms. And then I have my, I don't have my blue highlighter. Oh well. Okay, and then I have my constants. So let's go ahead and look at our next step. Okay, I just kind of highlighted my like terms. So your whole goal is to isolate the variable. And we're trying to get all the variables, right, to one side. So the next step is to move the smaller variable term, move all variables to one side. So the smallest variable is actually my 4x, right? Because look at the number in front. Which one is least in value? My 4x. So let's take that little guy over here and move it over to its friend 8x. Now, when I move it over, right, I'm going to do the opposite sign of what it is. It's a positive term, so I'm going to subtract that term from each side. Now, am I going to put the 4x underneath my orange term? No. Okay, I'm going to put it under its like term. You don't want to line up unlike terms. It's going to mess you up. That's a very common mistake. Okay, now draw your line and always rewrite your equation reading it left to right. Okay, so here we go. Let's combine these two terms. We have 8x minus 4x. That gives us 4x. I'm going to rewrite my 7 because I didn't use it. Okay, this cancels each other out, right? That makes it 0. And then it all should equal 21. Okay, now I'm on my next step. Move constants to the opposite side of step 2. Well, since I went right to left, I got to go left to right with my 7. So we got to take this over here and move it to the opposite direction. Okay, so again, remember, undo the opposite sign. So it's like a -7. So I'm going to add 7 to each side to undo it. That cancels it out. Now I'm going to bring down my 4x. And 21 plus 7 is 28. Now I'm at the solving part. I'm at the very last step. And what I want to show you, and usually this is when it comes down to the very last step and you have to solve, it's always undoing addition or division. It's always going to be one of those two. So what is the inverse? I'm seeing multiplication. So to undo multiplication, think division. So we're going to divide each side by that 4 in front. And that cancels each other out. And we have x equals 28 divided by 4, which is 7. Now, what's nice with two-step with any equation is you can check yourself before you wreck yourself, right? Okay, so I'm going to go and pause the tape real quick and grab my calculator so I can show you how to check it. So what I'm going to do is I'm going to take 7 and I'm going to plug it in on the left side, and I'm just going to do one side at a time. And they should equal each other. So we have 8 times 7 minus 7 equals 49. So if I did it correctly, the right side should also equal 49 when I plug it back in for x. So let's see, we have 4 times 7 plus 21, 49, yay! Check, I did it correctly. Awesome. All right, let's go ahead and move on to the next. All right, I'm gonna again follow my steps. Step 1, draw the wall. Step 2, move the smaller variable term using addition or subtraction or positive negative. Move all variables to one side. Okay, so let's look at our variables right here. The terms with the variables in it. We have a negative x, negative 11x, and we have negative 2x. Well, which one's smaller? This one, right? So I'm gonna go left to right this time. Okay, and I'm going to do the opposite sign. In order to move the whole term, you gotta use the opposite sign. So if it's a negative term, think add that term to the other side, because that will cancel that puppy out. And make sure you line up your like terms, okay, because it's going to mess you up if you don't. And then rewrite your equation left to right every time you make a move. All right, so now we got negative 2 plus 11, that's 8x, and I'm going to bring down 45 because, again, rewrite your equation left to right every time you make a move. Okay, now I'm going from step 2. Okay, here are our constants, right? So since we went, all our variables are on the right side, all our constants need to be on the opposite side. Okay, so I'm going to take this 45 and I'm going to move it over here by doing the opposite of what I see. So I see addition, so think subtraction. 45 minus 45, that cancels each other out. 9 minus 45 is negative 36. Okay, hold on, I think I made a mistake. Oh, here it is. Silly Mrs. Dan. It's not 8x, it's 9x. See, I was going to get a decimal, so I knew I did something wrong. Okay, I can't subtract. All right, it's okay. It is the weekend. So we have negative 36 now equals 9x. And like I told you, most of the time, it's not even going to be this one. It's going to be this one. So we got to undo addition, multiplication, or division. So I'm seeing multiplication, so I think, that's right, division. Okay, so divide each side by that number in front of x, and x equals negative 4. Okay. Now, I know this might be a little on the tough side. I know. Okay? But this is just the beginning. So why don't you stop the video and try to do 3 and 4 on your own. So hopefully you had a chance to do this and complete 3 and 4 on your own. So let's talk about it real quick. So I started with my 6x and I moved it over here. Now, honestly, you can start with any term. That's fine.